Hello, students, and welcome to Dilations. We're going to dilate time to change how quickly this recording is going.
Wow, I did not know where we were going with that. That was an exciting adventure.
I figured. Uh, so we've talked about dilations a little bit in class before as an example of a non-rigid transformation. That is one that does not preserve both size and shape. It's not a congruence transformation. We often think about dilations as kind of using a copier, which is a device that we make paper copies of things on that you may or may not have ever seen before, wink, wink, and enlarging or shrinking images. And we can see that's what's kind of happening here. Where we have our triangle that's PQR, and it is being blown up, for lack of a better word, to become P prime, Q prime, R prime. And by lack of a better word, I just didn't want to use the word dilate again.
So you're saying the black image, PQR, kind of grows into the larger image, P prime, Q prime, R prime.
Yeah, so it's like I kind of think about this like we have this little light shining here, and P prime, R prime would be like the shadow image of PR.
Where C would be where the light source was?
And C would be where the light source was.
So C, they're saying, is the center of dilation. Is that what that means?
Yes.
So everything is kind of growing from that center?
Yes.
Now, for us in this class, most of the time, our center is going to be the origin.
That is true.
Doesn't have to be the case, and isn't the case on some of the Khan Academy adventures you will go on. But it will be the case on like your assessments and things like that.
That's fair. Do you like my little flashlight?
Oh, I was trying to. I thought that was a mustard stain. Now I get it. Okay.
There you go. Or as the Brits might say, a torch.
Yes. So for any other point, R prime is on there. What the heck does that mean? I don't get it.
So we're talking about a length here. And here we're talking about CR prime is going to be some version of a length. I actually really don't like this definition because we're talking about comparing the length from this, if we want to use light source as the idea for that, to the whole length from the light source to the new R prime, which is totally fine. That's a legitimate comparison. But if we're just learning about dilations, that's kind of a confusing comparison. What might be better to think about is that whatever I have to multiply QR by to get the length of Q prime R prime is going to be the same as what I have to multiply PR by to get to P prime R prime as far as the length.
So is this kind of like the idea of a scale?
Yeah, in fact, sometimes we call this a scale factor.
Got it.
Not a scare factor, but a scale factor.
Scare factor is what Mike and Sally deal with.
Yes, it is. Took me a second there.
I heard the processing. That was good.
Because I thought you were talking about whatever the Fear Factor show.
Never seen
where
that.
they used to have to put their like hand in a box of spiders and stuff.
Never seen that.
Neither have I, but it's one of the random pop culture things I have. Anyway, so we're talking about things that we're going to call enlargements or reductions. I wonder what those words imply.
It said scale factor right there.
Oh.
That's exciting. It's like we predicted the future.
We did.
So an enlargement means we get smaller.
I feel like you're lying there.
Oh, darn it. An enlargement means bigger, and a reduction means smaller.
Okay. So for the first image, that is the image on the left, we have a scale factor of 2. It looks like the image is twice as big as the pre-image in terms of the lengths of these sides.
So whereas CD is 4, there's 2, I'll try it again. C prime D prime becomes 4 because 2 times 2 is 4.
So it is more bigger by a scale factor of 2.
Yeah, so I think one thing to keep in mind, and 2 and 4 are terrible choices for this, is this is a multiplication problem, not an addition problem.
Yeah.
So you're doubling that 2. You're not adding 2. I understand that 2 plus 2 and 2 times 2 are the same number. Second one's a better example. We go from the outer image, E, F, G, H, to E prime, F prime, G prime, H prime. We go from 8 to 2. We're not subtracting 6. We're dividing by 4 or multiplying by a quarter. And that's a reduction in size.
So you're saying that dividing by 4 is the same thing as multiplying by its reciprocal, a fourth?
I did sneak that in there, yes.
I feel like that's a thing that's a really helpful relationship to know.
It is.
And there's one other useful thing that I like here, which the notation's a little bit weird. So they're also suggesting that all of these lengths, that the ratio from the new length to the old length, in other words, the scale factor, on all of these things is going to be the same, no matter which matched lengths we're dealing with.
So does that mean, like, so for ABCD, if this is, say, 3, then B prime, C prime has to be 6?
Yes, because those are lengths that go together. We can tell because they're named the same, but with primes, and the scale factor has to be the same.
And so if this is 1 here, this would have to be 4. Same idea.
And if this were 16 here, this would have to be, I like how I put 2 there, but I meant to put a 4 there.
You confused me. I was like, wait, did I mess something up? Did I do something wrong? So that's supposed to be 4, because 16 divided by 4 is 4.
I'm going
And
to
if you sort by the division, you could think the other way. 1 times 4 is 4. 4 times 4 is 16. 2 times 4 is 8.
It's true. All right. And now we're talking about, this is the image.
Same thing, kind of a different piece.
So this is the one that you were telling me that I was going to hate?
Nope.
Oh,
not there
okay.
yet. We're going to get there. There's an image coming up, friends, that Mr. Carlson is going to go when he sees it.
So for example, if this were, let's say we knew it was a scale factor of 4, this is one of the tricky things about this. I think this is a good time to talk about this. If CP was, I don't know, 7, we often try to say that PP prime would have to be 4 times 7, but that's not accurate. It's the length of the new thing from that center of dilation to the new point would have to be 4 times 7, not the extra length that we're adding on there.
So if they asked us, if they didn't tell us this, and they told us the scale factor was 4, or n was 4, and they said that this was 21, we could verify that this is true by saying 7 times 4 is 28, which is that whole distance, 28.
Mm-hmm. And if you remember way back to like middle school stuff, you had things like fraction bars and area models to deal with this, where you'd break this up into 4 pieces and have to say, okay, if this is 7, then we have to have 3 more 7 pieces to get there. Can you tell I've been tutoring a lot of middle school students recently?
Well, I don't have that content knowledge that you just said, so yes, I can tell.
All right.
All right, so is this an enlargement or a reduction? So we have to pay attention to who we start with and who we end with. We're starting with, that's apparently an X and an X prime there. We're starting with the black image, XRT, and we're going to the blue image, X prime, R prime, T prime. So we're going from black to blue. We're getting bigger, so that has to be an enlargement. Mm-hmm. And then what is the scale factor? Well, I see a side of 4. So is it fair to say that XT goes with X prime, T prime?
I think so.
And we're going from 4 to 8. So I think I multiply by 2 to do that.
I would disagree with you.
Oh, I did it wrong?
You did.
Is this what you warned me about?
It is.
Oh, was I supposed to go from 4 to 12?
You were. And I was a little bit confused how you did that because you wrote the right letters down.
I know, but I saw the 8, and so I assumed that the 8 was the whole distance.
One of the things that we often strongly advise students to do is to draw these things separately. So we have XRT.
Oh, that would have saved me trouble.
We know that that's 4. And then I'll do this in blue just to match the color. So we got R prime, T prime, X prime. And to get from X prime to T prime, that's this whole thing. So that's 4 plus 8, which is 12.
And that's times 3. So the answer is actually supposed to be B.
Bada bing. All right. Oh, there's some notation here.
What does that mean?
Uh,
We've got it. The D, I bet stands for dilation.
I bet it does too. N, well, we're given scale factor N here. So would it be fair that a general form for this would be scale factor? And then is that an O for, oh, the origin?
Yeah. See, it looks like a 0, but we've got to be careful. It's a origin. And again, most of our dilations for us are going to be from that origin.
So something that's on a spiral, we're going to use the origin.
Yes.
Something that's on Khan Academy, probably, but maybe not.
They have them from all crazy places. Wait. We're supposed to say enlargement or reduction. So we're going again from black to blue. Blue is smaller, so it's a reduction.
I like it. I don't see any lengths though. So because we have to figure out the scale factor for this as well. Something that I do notice is that I can kind of count from like the center to each of these points.
I like it.
So like going from the center to J, OJ is delicious, is going to be 2 units. Going from the center to J prime is only 1 unit. And I'm going to see if that holds true in other places too.
I think you should use K.
But that would be okay. So that would be X units. I mean, 6 units. It's kind of awkward to have the X at that exact place.
It is. It's a little confusing.
And then OK prime, 1, 2, 3, is only 3.
So it looks like the scale factor is 2.
It does. Going backwards.
I was trying to trick you.
I also noticed that we can do this diagonals too. This is only 1 diagonal, and this is 2 diagonals.
The intent behind this may be to find the length using like Pythagorean theorem stuff, which we haven't done yet. But that may be.
I don't think it is.
It's not.
Like based on the way that they introduced this first, using this type of thinking. The other cool thing that I think is nice here is we can see that these dilations are all on the same line from the center for each of these.
I like that.
And that's a really important thing for dilations, because you can show dilations pretty easily, and you can make your own on paper using rulers. As long as they're all on the same line, you're okay.
So you're saying, since these are centered at the origin, if I draw a line from the origin to one of my vertices, or to the outer vertex, it should go through its corresponding inner vertex?
In fact, it has to. And one of the ways that we do dilations by hand is to draw those segments in and to manually cut those segments in half. We have these things called constructions that we can find the midpoint of a segment pretty easily with. So this is an example of one that we could do by hand without too much work.
Got it.
Cool. All right.
What are the coordinates? Identify the coordinates. Use that relation. Well, I mean, this is like a rule. Sounds good. Can I set up a matrix? Would that be fun?
Sure. I'm trying to figure out this notation.
This here?
Yeah, D2.
They're assuming that the origin is there. They like showed us that other notation and then got rid of it. The notation in this book is interesting.
So really this would be d of 2 comma, I'm going to write 0, 0 instead of the origin because it looks like a face. Um, so would this be notation that's less confusing?
Yes. So I wrote down the original points. And you don't have to use a matrix here. I'm going to do it with a matrix, then we'll do it without. I just use it to organize myself, basically. And then I want to dilate by 2, as Mr. Carlson put there. So you just put a 2 on the outside. That's called a scalar, which works because this is a scale factor.
Oh, so we're scaling something.
Yeah. So all you do is you distribute this scalar to every single piece.
Pew, pew,
In,
pew, pew,
yeah, you need that.
pew.
So that goes to 4, -2, 0, -4, and then -4, 2. I like how it says graph that, but then you can't on the and so these are the points. So this is P prime, G prime, and Z prime. Now you don't need to use a matrix. If that just blew up your brain, you don't need to do that. You could simply write down the points. You could say P is 2, -1. So P is 2, -1. So then P prime is 4, -2. Like you could,
Oh,
that's
because you're
fine. It doesn't
doubling
matter.
the x and doubling the y.
Yeah, you're just multiplying by 2. So like if you wanted to notate it that way, go for it. It doesn't really matter. If you see a matrix with a scalar on the outside, now at least you know what to do with it. But you don't need to set that up if that confuses you.
Is this the one you think is going to bother me?
Yeah, because the images are terrible. They're so fuzzy.
This is fine. I don't know. I don't know what we're doing.
There are no
But
directions on this page. That's also an issue. My assumption is to
scale
figure out
factor?
scale factor. That was my assumption.
Okay. I'm just going to call this A and this B, since those are the only numbered pieces that we have. And then we might be able to deal with that. I don't know. Although I guess this should probably be, are we going from dotted to solid or from solid to dotted?
I'm assuming we're going from solid to dotted. So this
Okay.
is a terrible page in terms of directions. I left it here because I thought Mr. Carlson would get annoyed with it, which he is. So this page, what they want us to do is they want us to figure out the scale factor from dotted to solid. And it's an interesting page, and the images are fuzzy, but we're going to roll with it.
No,
So
you just switched around what you were saying.
Sorry, solid to dotted. Solid to dotted. I apologize. So you're saying I should pay attention to XA
Yeah,
and
and
then XA prime.
I would say x prime a prime. I know we don't have to, but I think that that's helpful to do, especially if you decide to split this into 2 triangles to kind of show what's going on, which we did recommend that students do.
That's true. So we should draw that.
We should.
Okay.
And if you want to do the triangle, I'll get the trapezoid ready, or trapezoid
Sounds
thing.
good. Okay. So I have XA, and then I have X prime, A prime. So XA, careful, don't mess this up. XA is 5, and then X prime, A prime is 3. So that means that the scale factor, we're going from 5 to 3 is, let's see. So we're going from 5 to 3. So what am I multiply 5 by to get to 3? So 3/5. How'd I do, Mr. Carlson?
You did great. I like it. All right, so we're doing the same thing, but different for our trapezoidy type things. And we're going from BW to B prime W prime, going from 4 to 8. And I'm going to treat this a little bit differently than Mr. Butterworth did, just to kind of, if you're confused where that 3/5 came from, give you some help to get there. So we've got 4 times some scale factor, we don't know what that is equal to 8. We could solve this algebraically and say, okay, to get n by itself, we're going to divide both sides by 4, and we get a scale factor of 2.
I wonder if that's going to bother the students that you put the divided by 4 under the n and not under the 4. They should email you some anger-filled emails for that. They won't, but we can.
I know, but that's okay.
So you're saying I could have, on the one I did, because you noticed my hesitation, I wasn't sure how to explain it to them. I could do 5n equals 3, solve for n, and I get n equals 3/5.
You do.
I could have thought about it that way too.
And I think especially if, so this is a part of math we call proportional reasoning. A lot of us humans are really, really in struggle town when dealing with this. And this is kind of a good way to get around some of that if that's someplace that you have trouble kind of processing.
Well, and my first instinct was to write 5/3 as my scale factor, but that's why I had to articulate, I would need to get from 5 to 3.
Right.
So I knew I needed to use a smaller number. And so that's where I came up with the 3/5, but I like the structure of 5n equals 3.
Cool.
So this is the same idea that D7, Mr. Carlson rightly is pointing out, they mean D with a 0, 0. There we go. And so we're taking the point 3,4 and we're dilating it by a factor of 7. I'm not sure why there's a graph on this page because I'm not graphing that.
That's 3,4. And we're going to go 7 times as far. And that's going to be 7 times 3 is 21. 4 times 3 is 28. Cool.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Why didn't you just go here?
It's not to scale.
But then you would have gone 7, 7.
Because it's not to scale.
It would have been easier.
It's not to scale.
Whatever makes you happy. But anyway, I wouldn't have graphed that. That's silly.
Yeah, that is kind of a weird thing.
But all you're doing, you're multiplying the x and y by the same number because we're dilating from 0, 0. If we're not dilating from 0, 0, things are different. But that's why we're not asking you that question. On the Khan Academy questions, they don't necessarily have a center of the origin, but numbers are not important to them for that.
Yeah.
So it's not.
I think that's a good way to phrase that.
That was like a slow motion and we brought it back.
It also, I got to shiver a little bit looking at this and being like, I really hate this notation. This notation really bothers me more than the rest of it. Yeah, I know, but then we couldn't see the.
I know. Okay, so complete the statements about the dilation below. All right, so I don't know what the first one asked me to do. So I'm going to go to the second one. That's going to be, we're going to multiply the x by 4. Yeah, that's what I was going to write.
Oh, I thought that's what...
This is all in a line. I get it. So a is going to go to 4, -8. I get it. I understand. And then it's going to be 3 times 4 is 12. And then 5 times 4 is 20. Oh, you're putting in words. What that means. Dilate ABCD by a scale factor of 4. So if C prime is 28, so from left to right, we multiply by 8.
About the origin?
From the origin.
From's not the right word, though.
Centered at the origin?
I'll use centered. We use kind of weird words for these. Like you reflect in a line.
I reflect over a line.
But that's not the mathematical way to say it. It's reflect in a line.
Maybe I'm not mathematical. Anyway, from left to right, I multiplied by 4. So from right to left, I unmultiply by 4. Which is also called dividing, if you're curious.
Or factoring.
So 20 divided by 4 is 5. 8 divided by 4 is 2. 20 divided by 4 is still 5. The center of dilation is 0, 0, since they didn't write anything down. So that's the assumption we're making.
This notation's terrible.
I agree. We will, in general, not use that notation. The only notation we'll use will be the dilation with the factor, which are called a scale factor, and then the center. That's the notation we would use, but we don't care that much about dilation. So, or sorry,
right.
about notation, not dilation. Different word.